we actually have cadaver data for something. I'm trying to think what the project was. I don't think we've done the project yet. I think it was to get as many skin fold measurements as we can and link it to belly fat. Something like that. I'm not quite sure if we have it like that. By the way, I haven't done this yet, so I'm curious how good the constant rule does on actual a person. And go and see what you guys are drawing, so I'm curious. So which one's which? The black one. Okay. So they're that's very similar to the weight graphs. Constant rule for weight graphs. They pull off real fast. Yeah, my constant rule like that too. What does your look like? Yeah, it looks like it's leveling much faster. So is this this data that I just had?
Yeah, I have one up here, but it was too small, so
You put the constant rule on top of it, overlay it, and see how good of a match they are. I wonder if it's going to go down below, right? I don't think they have it. I don't think they have it after 9 hours. Yeah, they didn't have it after 9 hours. Does everybody have this data? I'll give you another set. You can overlay another set because the problem with one person is one person's not enough. So the other set is started out. You know, I do think they were sick, right? I mean, this is not fever. This is not a fever, but it's higher than 98.6. The other one was too, a little bit. That's a second set of data. See how good. Try to make like, I don't know, in Excel you have different shapes that you can make for the dots. So overlay, instead of making dots, put maybe little triangles so that you can see which one is better. I mean, is it fitting one of them better than the other? When medical research has really changed since initially, if you look back at the 1900s when they first started collecting the data and putting it into books, where we have still access to them today, these kind of studies were done back then, where they just collect tons and tons of data and they carefully measure everything and put it into a book. There's actually a 3-volume set in the library called Human Starvation, where they took, I think it was 32 young men who were supposed to fight in World War II, but they didn't want to. They called themselves dissenters. And so they gave them the option of enrolling in this experiment instead of going to war. And they semi-starved them for a period of 24 weeks, and they refed them. The idea was that they are going to need to know how to best refeed people after the war's over because there's so much famine across the world. So in this experiment, 3 volumes of just data. Urine was collected on all of them. Everything was collected every day. Everything was so precisely measured. 32 people. You can't run studies like that today. Number one, you won't get past the Institutional Review Board if you're going to do something that's going to be that tremendously tough on people. But second, you can't run, like you need to have a small study to be able to collect everything on everybody and manage it. And these days, you won't get funded for doing that small of a study. Rarely, it's really rare. So if you want to do a study, you have to say, like, I'm enrolling 200 people. You can't just do it with 5 people. So these studies that from the old days, as a mathematician, to me, it's really valuable. Because it's all I got, really, in some cases. So what do you think? The second graph?
It's closer, but it's still like not the same. Like the first graph is like theoretical one was like steep.
Okay. So that's what lines do, right? It's a line. Lines are, once you say this is the slope of the line, you're done. This is the slope is the grade. So this grade of this is negative 1.5. That's what it is, right? It's supposed to drop 1.5 every hour. That's the rate. That's the speed of the drop. And once you say it, that you're done. It might be negative 1.5 at some place, but it's not everywhere, correct? So if you need to somehow let the slope change too in order to make the thing match up to the data. But a line doesn't have slope changing. It's always negative 1.5 all the way through. So maybe when the person's the first few hours, their temperature drop will be really big. That would make sense, right? Their temperature's up here, room temperature's down here. There's going to be a push to get that temperature down fast. But as they get closer and closer to room temperature, what do you expect to happen? Maybe that speed would be slower. That's calculus. I just explained calculus there with this one little example. That is it. It's about slopes being functions of time. And now you can see immediately why that's important. You can just see it from this temperature problem here. You'd want that slope to be a function of time. If it's a function of time, are you going to get a line? No. You're going to get a curve. You're going to get a steep drop initially and then a leveling off. So instead of the curve we had, I saw some of your desks drawing it. Would you agree that it's, in medicine we say curvy linear. It's not linear, it's curvy. In math we call it nonlinear. So I would say, as Cassandra was suggesting here, that the curve would look something like this, 98.6. Initial drop is steep, and then I would expect it to do this. And what would this line be where it's limboed, can't go below? External temperature, room temperature, it can't go below that. So if this is temperature, and this is time in hours, I would expect it never to go below that. I think that's what it would look like. What do you think? Looking at your real data, right? Make sense? Okay, so what does that curve look like? Let me use the same letters I have here. Looks like this. E is this weird number, 2.717. And these are all what we call parameters. And this law here is a law of physics. This comes from a law of physics called Newton's law of cooling. So a constant rule, this happens all the time, by the way, in medicine. A constant rule is applied because it's simple. There is a real rule out there from physics, but it's more complex. So may the two never meet. But this is easy. I can program this in 2 seconds. In fact, I'll do that for you guys. I'll put it into a program where I can just use slider bars to change the room temperature and change the R and change the C. So this C and R and the K, they have meanings.